Arc fault is common in our life. You could see an arc fault because of damage insulation, because of furniture, because cables are getting old in the installation, or simply by just poor installation. This is the case of AC, our daily life, let's say. The good thing is for, let's say, for indoor, for houses, for our daily life, arc fault could come in the form of AC, and which naturally, as you know, has a sinusoidal form. This means that every half a cycle it goes through zero, and which means the arc fault will extinguish by itself, reducing the hazard, basically. So now arc faults on PV systems. In PV systems, we have a DC size on the modules. After the inverter, we will have the AC part of the installation. And now on the DC side, if there is an arc fault, this is considered more hazardous because this will not be extinguished naturally, like in the case of AC. The arc fault will be there until there is someone take measures about it, and this could lead to some serious damage. Some common causes of arc faults on PV systems are poor welding on the junction box of the modules, using the wrong connectors or mixing connectors. Normally, when you use a connector from different manufacturers, or even the same manufacturer but different models, there might be a gap between them, which could lead to an arc fault. And also broken DC conductors due to aging or to, let's say, errors in installation. Sometimes we have seen the DC cable is just going around the edge of the structure, a metal piece on the structure. So this potentially could, let's say, damage the cable and create an arc. The problem with this is, as I was saying before, high temperatures, very high temperatures can be reached with an arc, and this could lead to a fire. This is especially dangerous for residential and commercial sites. And also this could possess a risk for the O&M staff working on the roof, because there will be a live conductor exposed. And just to give you an example, this is a famous case. Some of you might have heard between 2012 and 2018, the supermarket, American supermarket franchise of Walmart had experience on fire in some of the stores in the roof, and this was identified as a problem with the PV. And then the main reason was because of poor installations. After some inspection, they were found loose connections or cables not securely tight. They were just hanging around. So these are some potential installation hazard that led to fires, around seven fires between 2012 and 2018. And as you can see, this presents a significant hazard because there are places where usually people is around. So in order to avoid this, there are some international standards. The most commonly known are from the United States. First, we have the NEC from 2017, specifically for photovoltaic systems. And it says that every photovoltaic system working at or above 80 volts must have an AFCI capabilities, arc fault circuit interruption capabilities. And then you have also the UL 1699B, which also stipulates that a photovoltaic system must have AFCI capabilities in order to detect arcs of 300 watts or more. And it is important that this is clear within 2.5 seconds. And they make the clarification is for series arc. I will elaborate more about the type of ARC later in my presentation. Then for Europe and international standards, we have the IEC 63027, which has been in development. I believe it's in their final stages. This standard was supposed to be released this year, but due to the current situation, I believe the final version has been postponed to the next year, but sooner than later, we will have this IEC standard for us to use in Europe. So now, just a brief description of ARC4 classification. First of all, series ARC. This is an arc present between a conductor and the same polarity, let's say the positive or the negative. This is the most, we have identified this as the more commonly arc that can happen on the installation, and this is why all the standards mainly refer to the series arc. Then you have a ground arc. As you know, this is just a ground fault. This, in the events of this happening, this can also be detected by your insulation resistance system or your RCD. So we are familiar with this. And then parallel arc, which is an arc created between conductors of different polarity. In the case of a PV string between the positive and the negative, this can occur because, as you know, sometimes the positive and the negative wire, they run very close parallel to each other, for example, on ground mounted systems, also on rooftop applications. However, the chances that a same, let's say, breakage or crack between the insulation happens at the same point is very unlikely. So this situation is not really very common on PV systems. As I was saying before, the standards are focused mainly on series arc because this is the one that occurs the most. Both the UL 699B and the IEC 63027 focus on the detections of series arcing. Just to give you an example of the UL 699B, these are some of the requirements that you need to consider depending on the power and the current. There has to be a certain clear time. The maximum will be 2.5 seconds. And also in the last update, they are clarifying that the conductor must be a length of, they must be capable of detect the ARFO for a conductor of a length of 80 meters, which I'm gonna elaborate later as well. So currently, what solutions does the industry has for ARC4 detection? You have two cases. First, when the inverter itself doesn't have that built-in ARC4 circuit interruption capabilities, then what you can do is you could have a DC combiner box with AFCI capabilities, or just a box that have AFCI capabilities. The problem with this is this will bring higher costs to your installation, and the high frequency switching of the inverter and the other components could interfere with the reading of this box. So the reliability in detection of AFCI of this type of solution is normally not very accurate. Then you have the case where the ARC4 detection circuit interruption is built in the inverter, and then the manufacturer is responsible for taking into consideration everything that happens in the inverter in order to be accurate on the AFCI capability. So this system will be more secure, and you don't need extra components to install. So, but even when you have built-in ARC4 circuit interruption in your inverter, there are some challenges. The first one is, as you know, the arcing could be could be read as a high frequency signal between 10 kilohertz and 100 kilohertz. And the AC component of this signal could be analyzed. As you can see here on the picture on the right, you have a system where we are reading the signal of no arc situation and our arc situation. So we focus on identifying this noise in order to be able to differentiate this scenario from the scenario where there's an arc, and then there is a clear difference on the noise and the frequency spectrum. And once we analyze this, we are able to identify there is an actual arc fault. However, this is challenging. The other challenge is that there is, as I was saying before, there is on this signal there will be interference as well, and there are two situations here. The interference could lead to two problems. First, the solution is missing an actual artful situation because of interference. Typical challenge is the attenuation due to the long DC cables. If you have a very long string and the fault is located very far away from the inverter, then the signal will attenuate, and this will make it more difficult to differentiate the case with no arc and with arc. And then due to the capacitance formed on the PV modules and the inductance on the DC line, this will also attenuate the signal. So your system needs to be, it will be more difficult to identify the arc fault. And the other is that when the system actually identifies an arc fault, but it was actually a false arc fault. This could happen because, first of all, long PV cables, PV cable making rounds, which are very common, they have some sort of antenna effect, and so they are capturing signals, and this could mislead your AFCI system to trigger a false alarm. Then you have a high frequency of extra components like optimizers. This will introduce some variation to the signal, and again could lead to misleading or a false arc fault event. And finally, the common mode noise between several inverters connected in parallel. This could bring again challenges to identify a correct arc fault situation. And these are for the external factor. Also with the internal factors, and now with modern inverters, which are moving away from just being pure converters, DC to AC, to high power electronic equipment. There is a lot of switching, high frequency switching. This will create a lot of noise as well. As you can see that in this image, the signal from a pure arc and the signal within an inverter, because this is inside the inverter working in a normal situation, you will have some peaks because of the switching that could interfere with the arc signal and could lead to a false arc. Some of the common internal disturbances are the MPPT operation, the switching noise because of components like IGBTs, and optimizer switching in the case you have them. So again, this is a challenge that the manufacturer needs to take into consideration when developing AFCI capabilities. So in the practice, the problems that this will have is for the installer, for example, the installer could get a lot of complaints because the system is falsely tripping or is actually not detecting the arc fault, and it's creating some hazard for the building. And when there is fault tripping, you will need to go continuously to site to do some troubleshooting and some maintenance. And of course, as we know, with this comes with a cost related. This is for the installer. For the homeowner, every time your system is triggered by a false alarm, the system goes down. And this are times where your system is not injecting. If you are not injecting, you are not making any revenues. And of course, the safety part. If the air fault is not detected, then this will present a hazard for the people around the system. So now I will describe the efforts of Huawei to approaching this solution. As you know, some of you that are familiar with our solution, our first generation of inverters, they did not have AFCI capabilities, but we are focusing our efforts now on bringing these solutions to the market. Our new generation of inverter does have AFCI capabilities, and in the future, all of our inverters will have it as well. So the main, the principle of the AFCI with Huawei is we are using our AI boost, artificial intelligence, and high power algorithms in order to accurately detect an artful detection. Basically, is an algorithm that is being fed with cases after cases, so it's continually self-learning. So and we are learning cases of artful detection globally. So basically, the way it will work is the inverter through firmware updates will update the AFCI algorithm and will be capable to identify more cases and differentiate cases from false AFCI from a correct AMCI. And we have done this, and we have tested this. The tool, the capability is very accurate, and it has very good response times. One important thing to note is that we don't take any kind of data from the site without, of course, the previous consent of our client, and this is not taken from any cloud as well. This is an example of some tests we have done for our units. As you can see, if you remember, I mentioned on the UL standard, the limit was 80 meters. We have tested from 61 to 200 meters, and we have done a arc generator, and we have also incorporated a ballast resistor. So we have followed all the procedure. As you can see here, we have tested the cases with optimizers and without optimizers, with different parallel inverters, as you can see, because as I mentioned before, there could be some common mode noise between the inverters, and the reaction of the artful detection is very, very fast. In the range of milliseconds, 300 to 200 milliseconds. We did over 100 test cases, and 100% of them we accurately detected the fault. This is unfortunately a video that we had due to constraints of the platform. We cannot present, but basically the video show when you have disabled the RFOG capability in the inverter, and then after you enable, the RFOG extinguish immediately. So on the practice, as you know, we have multi-MPPT inverters with very few strings, 2 strings per MPPT. If there is an RFOG on a string, you will be able to see in the app which string is the one faulty, so you don't have to waste time locating this string. So in the events of making some repairs, or some amendment for this fault, you can just go directly to the string. This is, as I mentioned before, not all of our inverters have the AFCI capabilities. Our new inverters, the small 3-phase and the residential, they have AFCI capability. Our old 33 KTLA unfortunately doesn't have it. We have a 36 KTL optional with our AFCI detection, and our 60 KTL cannot do it. Later we will release a version that will be able to do it. And now the new 100 KTL MO in Q3, we will release a version with AFCI capabilities as well. So, and finally, for the alarms, it's interesting to know, according to the UL standard, if the arc is extinguished in less than 5 minutes, there is no require a manual reset. But if you have 5 events on that same day, then you have to shut down the system for 24 hours, and then a manual reset is necessary. Then in the IEC, what it's prepared, as I said, this is not final, but this is what they are preparing. If the arc fault is extinguished within 3 minutes, then the system is allowed to continue. In the case of retripping, you need to wait 10 minutes at least. If you retrip 5 times in the same day, then again, as the UL, you will need to wait 24 hours before connect the system again, and the reset has to be manually. For the times that this is why it is very important to have an accurate AFCI system, because as you can see, you can be a whole day without producing, which if you add this to several days in a year, it could be a significant amount of yield that you are losing. It is also important to have a fast reconnection system when you are allowed to connect remotely, and you can do this if you have our dongle or a smart logger without inverters. A remote reconnection will be, or alarm clear will be allowed and possible as well. Well, thank you. This is